Hello everyone. The next acidic comparison will be among these four molecules: orthofluorophenol, orthochlorophenol, orthobromophenol and orthoiodophenol. These three already we have compared, and this one either will be less acidic than these three or can be more acidic. So no need to compare these three in this video. Already we have compared them. Order was increasing order. Iodo case was least acidic, followed by bromo, and most acidic was chloro. So in this video, I will not compare these three. The topic is for 12th, JEE and NEET. Let's start the comparison. The same technique I am going to apply. I will make their anions after loss of H positive and I will compare their stabilities. This will be the anion produced from orthofluorophenol after loss of H positive. This will be the anion which is generated after loss of H positive from chlorobromoiodo. X is representing here chlorine, bromine, iodine. Because these three we no need to compare here. We have to compare them simultaneously with orthofluorophenol. Now we will check their stabilities. The very first factor, this factor is available. What we call it, plus R of oxygen, which is making stable these compounds. Because due to resonance, you can check the negative charge of oxygen will finish. This effect is known as plus R of O. And it's a stability factor. It is available in both. Like this. Please draw all resonating structures by yourself. And you will find out due to this resonance, the negative charge of oxygen is finishing. As the negative charge will finish, it will become stable because it is unstable due to this negative charge. So that's why I have written plus R of O stabilizing factor, making it stable, which is available in both cases. Now next. As you can see, the benzene ring is attached to the substituent which have a lone pair on it. And we know these lone pairs can be donated by substituent in resonance like this. It is present on ortho position, and due to this electron movement, electrons will come here, due to which the negative charge of oxygen can increase. Means plus R of F will be a destabilizing factor. Destabilizing factor. Same problem here. Lone pair can be donated in a resonance, due to which, and it is present in ortho, so electrons will come here. Try resonance by yourself, due to which the negative charge of oxygen can increase. So plus R of X will destabilize the anion. Now before moving to next effect, we should clearly understand difference between plus R of chlorine, bromine, iodine and plus R of fluorine. As in previous video, I have already told to you, the plus R of chlorine, bromine, iodine is very weak. Reason? Atomic orbital size. Chlorine is using 3p orbital, bromine 4p orbital, iodine 5p orbital. Means these lone pairs, if chlorine is here, they are available in 3p. If bromine is there, 4p. If iodine is there, 5p. And carbon is using its 2p orbital. You can check chlorine orbital, bromine orbital, iodine orbital bigger than carbon orbital. So this proper overlapping will not happen. Like this is the lone pair of X and this is carbon's orbital. X orbital is very big as compared to carbon. So this proper overlapping will not happen, which we need for plus R effect. Already I have discussed this in previous video. That's why plus R of X is very weak here. Very weak. But this problem is not in a fluorine. That's why fluorine is different from other chlorine, bromine and iodine. Why? Because fluorine atomic number is 9. If you will do its electronic configuration 1s2, 2s2, 2p5, means these lone pairs will be available in this second energy level. In 2p, 1 unpaired electron will be there, which it is used to make covalent bond with carbon, and 3 will be available in 3 lone pairs will be available in second energy level. And carbon also have 2p, means the size of fluorine atomic orbital and carbon atomic orbital will be almost same. If diagrammatically I draw, it will be something like this: carbon and fluorine. Their atomic orbitals will almost have a same size, due to which fluorine can easily donate its lone pair for plus R effect. You know, in plus R effect what is happening? It is donating electron. Those electrons will be shared between carbon and fluorine. So carbon is providing orbital, fluorine is providing orbital in which lone pair is there. If orbital size is same, this effect can be easily done. The plus R effect of fluorine is very strong here. By this factor, it is differ from other. So here plus R of fluorine is very strong. Reason: atomic size of fluorine is almost same to carbon. 2p orbital both are using. Okay. So now third factor. Fluorine is more electronegative than carbon, so obviously it will attract electrons, due to which oxygen negative charge will decrease. This effect is known as minus I effect. And it will be a stabilizing factor. So you can check here, fluorine is showing two effects, plus R and minus I. One effect is saying destability. One effect is saying stability. One effect wants to destabilize it, this anion. One effect wants to stabilize it. Out of these two, who will win? Minus I. No doubt minus I will dominate here. Only these are the cases, fluorine, chlorine, bromine, iodine, in which minus I effect is dominating over plus R. It is dominating. Means overall the anion will become stable. Dominancy of minus I effect will be there. Reason: because fluorine is most electronegative atom, highest electronegative atom in the chemistry. So obviously its minus I effect will be very strong. That's why its minus I effect is dominating over plus R of its. Okay. Here also, I told you chlorine, bromine, iodine, minus I effect was dominating, which is a stabilizing factor, was dominating. Means overall this anion is also getting stability. It is also getting stability. It is also getting stability. But one anion is getting less stability as compared to the other. Which one? Check. This anion is getting stability due to minus I effect of fluorine. But you can check its opposite effect, plus R, is also strong. So this strong plus R will try to reduce the impact of minus I. No doubt minus I will win the fight. I already said dominate. It will win the fight. But somewhere plus R, strong plus R will reduce its impact. Means strong plus R of fluorine is making it weak. Again I am repeating, no doubt it will win the fight, minus I. But because minus I have to fight against a strong competitor, so it will become weak. But here such problem is not there. Minus I effect have to fight against plus R of X, which is weak. Already it is weak. Why they are fighting? Number one, why they are fighting? Because these two are saying opposite words. Plus R is saying, plus R is trying to destabilize the anion, and minus I is trying to stabilize the anion. So that's why they are two opposite factor. Minus I will win. Already I have said dominating. Dominating means it will win the fight. And because it have to fight against a very weak plus R, don't you think impact of minus I will remain strong here? This is the point. Means here the anion is getting stability, but due to weak minus I effect, means it is getting less stability. And here anion is getting stability due to minus I effect that was strong. So here it is getting more stability because it is getting stability due to strong minus I effect, and here it is getting stability due to weak minus I effect. Why it becomes weak? Because its opposition is strong. A tough fight is given by plus R to it. That's why overall it will become weak. But here the opposition is very weak. It will not give tough fight. Minus I can easily win the fight, so it will remain strong. That's it. So it is less stable. And it is more stable. Once we got the stability order of the anions, then we can make acidic order very easily. So stability order, this is 1, this is 2. Stability order of anion in increasing order if I write, so first is weak and second is more stable. It is less stable, it is more stable. And when I am saying 2, 2 means chlorobromoiodo. And what will be the order of chlorobromoiodo? Arrange by yourself, already we have discussed. Means ortho florophenol will be less acidic as compared to all other chlorobromoiodo. So stability order is this. So already we know what will be the acidic order. Same. Because the actual molecule knows that after loss of H positive, I will get less stable anion. So it will resist to lose H positive. Means it will release H positive with very much difficulty. If it is not going to lose H positive easily, so it will become less acidic. And they are ready to lose H positive easily as compared to this one, because they know after loss of H positive we will get stable anion as compared to this one. So they are easily losing H positive. So acidic order will be this. Strong acids because they are easily losing H positive, weak acid because it is not releasing H positive easily. So acidic order will be this. That's it. This was the order of orthofluorophenol and chlorobromoiodophenol acidic comparison. Thank you very much for watching the video.